2, 2. Yep, good. Perfect. Cool.
Holy cow. Woo! To the AV team, guys. All right. Too loud. They say it's too loud. I'm deafening them.
I can pull that back.
And we can't end with not having shots.
You did the shots. You're all rolling the dice to make sure you get drunk.
Gotcha.
I'm too loud for the microphones in Stable Talks. Seems like an accomplishment here. Achievement unlocked. So I have exactly like 20 minutes to teach you all about IT-OT convergence. How many of you know what OT is? So some of you actually know the word that's in the title of this talk that I have 20 minutes to teach you about. That's awesome. So hi guys, my name's Leslie, and hi. And I work for a company called Dragos, and I'm also known as Hacks for Pancakes. And my company does industrial control system or critical infrastructure security. And my job there is digital forensics and incident response on critical infrastructure industrial systems like power, water, oil and gas, manufacturing, transportation like air travel, trains, stuff like that. So stuff that goes mostly, stuff that does stuff. I've been in InfoSec for about 12 years now, and something I'm not admitting to in IT. And I do some other stuff. But basically, when a power plant gets hacked, I'm the person, one of the few people in the world who get called out to figure out what happened. So, have you ever been raise your hand if you ever get tired of all this new crap in InfoSec, like blockchain, next gen, cloud. You're all sick of it, right? Okay, so I've got great news for all of you. Great news, everyone. You too can go back in time and escape all this stuff. You can explore such exciting topics as Windows NT that can't be upgraded, proprietary and obsolete industrial products with no documentation, XP embedded computers with a mandatory 20-year life cycle, and extreme environments with safety concerns like very cold, very hot, explodes, good things like that, corrosive, all for the low price of all the modern threats that we have to deal with today in IT security, following you there like the Terminator. So let's start with some basic terminology in industrial control systems. So the first one I'm going to talk about a lot is processes. So when I talk about a process, I'm talking about a thing that happens kinetically in an environment. Your process could be making cans of tuna. It could be making 20-sided dies. It could be pumping gas out of the gas pump at the gas station into your car. There's all kinds of processes that surround us in our daily lives. They're usually digital, physical things, so things that an electronic system impacts, but there's lots of mechanical processes out there too. Before we had digital devices, we had cans of tuna made by something, some kind of machine. So processes are things like assembly lines. They're things that make a kinetic thing happen. OT, when I talk about OT, and I throw that word around a lot, I'm talking about operational technology. That's a common term for an environment where a process happens. So the OT environment is your factory, it's your power plant, it's your water treatment plant. It's these environments where these scary, interesting, awesome things happen that we're going to talk about today. Industrial control systems are the systems which control those processes. They make them happen. They make sure that the right amount of tuna gets in the can. They make sure the cans go the right speed down the conveyor. I don't know why I'm a tuna thing. I think I'm hungry. But anyway, we're going to talk about tuna. So we're going to talk about that. Now, a lot of people interchange ICS and SCADA. They are not interchangeable terms. And I don't have time to go into a huge description of why they are not interchangeable terms today. But industrial control systems can be non-digital things. They can be just a mechanical wheel, some steampunk gears that turn that make the tuna come out and go into the can and the conveyor belt go. They could be something from the 1970s where there's just a couple wires, and when the sensor feels a pressure on the plate, it dumps tuna into the can. You can have SCADA systems. They're awesome. Before we had SCADA systems, we had distributed control systems, which make a bunch of parts of the processes happen together at once. So you have a bunch of controllers out there that do various mechanical things, and it synchronizes them. But SCADA systems are even more sophisticated. Those are very, very fancy digital systems that organize your production timeline and know how much your production levels are per day and per hour, and all of that is dynamically changing over time by operator control. So that's kind of cool, but industrial control systems aren't necessarily SCADA systems. So please don't use those terms interchangeably. And please don't think that there's no digital industrial control systems that aren't SCADA, because there's lots of digital but dumb industrial control systems. So where do we see industrial control systems? So I do a talk called ICS Butts too, and ICS Butts is about how we use ICS as an exception everywhere. Like when we're talking about all these general rules we have in IT, we're like, yeah, scan your whole environment, but don't scan ICS. So we kind of treat these as exceptional situations, but ICS security is all around us. ICS are in electrical power plants that are keeping the lights on in this room. They are in manufacturing that got all of the supplies for this conference here, the transportation systems that ship them to their door. They're in oil and gas, which provides the gas to our cars and the heat to our buildings. They're in water treatment when you turn the faucet on. They're in logistics. They get aircraft from point A to point B. When you have any kind of automation in systems, and this has been the case for a long time, you have industrial control systems. They run the world. So we have a lot of challenges in OT environments right now. So the first one is pretty obvious. It's that these systems are really, really, really important to how we live, right? Think about all the things I just mentioned, all the verticals. They are things that are transparent to our daily life. You turn on the faucet, you expect water to come out. You pretty much expect the power to come on when you turn on the light, unless you grew up somewhere where there's really unstable power. We're used to these things working, and we don't really think about them working in the background. But they're super important. Think about Maersk being hit by ransomware a couple years ago, when the impact of Maersk being infected was overarching. It reached into all kinds of different industries. All of a sudden, we couldn't get Oreo cookies because their shipping wasn't working right. So ICS is something that goes ignored until something goes catastrophically wrong, until something explodes, or we turn on the faucet and water doesn't come out. And of course, that makes industrial control systems desirable targets for both insiders who are angry at their company and more sophisticated adversaries who are like, hey, you know what would suck? The power not going on when you turn on the light switch, or water not coming out, or contaminated water coming out when you turn on the faucet. Bad stuff, right? So yeah, bad people want to impact those systems. And because those systems are more and more internetworked, and there's a lot more convergence between our IT systems and our OT systems, they're looking very similar these days, they're facing a lot more of the commodity attacks as well that are impacting our IT networks. So yes, ransomware, if it moves over to an OT network, is going to do some bad things. That was interesting. That's just to keep you awake. I see on your phones back there. Anyway, this is super important stuff, guys. So so yeah, there's more commodity attacks out there. And I said earlier, we treat it like an edge case. We are like, yeah, patch all the systems, but yeah, not those ones over in ICS. We just don't do those. So we either ignore it completely, or we treat it as this weird edge case that doesn't affect us that much, when it's like the thing that impacts us most in the world. And unfortunately, as there's been IT and OT convergence over the last 10, 20 years, we've done a really bad job of interfacing with OT personnel. So we've come in there and we've been like, why are you running Windows NT? That's terrible. Get it off your network. And they're like, let me tell you the 15-page explanation of why I cannot upgrade from Windows NT. And we're like, that's fine. You're getting fired if you don't get that upgraded to Windows 2018 or whatever. So so we were horrible to them, and they hate us. And we also think that they're not doing their jobs, which is another issue. I mean, they really, in a lot of cases, are. Their job is making sure that the light goes on when you turn on the switch. So we have this antagonistic relationship going on between IT and OT, and that's a really big problem. There are also nearly infinite proprietary technologies going on in ICS and in the OT environments. There's tons of vendors out there. There's tons of verticals like we talked about. Think about how wide manufacturing is. You manufacture everything from like drugs and pharmaceuticals to like lanyards for your badges. Like, this all gets manufactured. This is all different equipment that makes this stuff. Like, so super wide vendor space, lots of proprietary technologies, and a lot of it is legacy. It's been around for a long time, and the systems that make your lanyards, they're not replacing them every 5 years. They're like really, really expensive systems, and they run older system technologies. And because of these legacy and obscure technologies, a lot of our familiar IT systems just don't work there, which sucks. So why do I do this job? Why do I work in ICS security, where I could be working with wonderful modern technologies like EDR and dealing with Windows 10 systems that have good security and stuff? Because this is super, super important. Industrial control systems run our world. And a lot of them are digital these days. Yes, there's still analog fail-safes and analog industrial control systems out there, but a lot of systems are now digital, and a lot of them are running on more IT-based systems because it's cheap and it's easy and people like it. So we really need to keep these systems secure. And I hope that you can, at least at the end of this talk, appreciate how important these systems are and how prevalent they are. And we're facing a lot of threats. So we're facing commodity threats because I said there's a lot of convergence between IT environments and OT environments. We're starting to see more Windows systems. We're starting to see more network connectivity. We're starting to see more commercial routers and things. These systems are starting to look a lot more like IT systems that are more familiar to us. And that means that they're vulnerable to things like worms, ransomware, and a lot of those things can have more of an impact on those systems because they're more vulnerable and they're more obsolete and they're less monitored. So they can have a big impact. There's insider threats. So there's, the ex-employee at the power plant who's really mad. One of the first cyber, take a drink, impacts on an industrial control system was a sewage treatment plant. This was long before Stuxnet in Australia, where an angry operator dumped tons of sewage because he got fired and he knew how to remotely control the sewage system. And it was a horrible mess. And of course, there's targeted attacks. There's espionage, learning how we do our operations in the United States for various reasons, and reconnaissance. So maybe they could shut off the power later, or make water polluted later, or do something horrible in the future when there's a case to do that. And there's, of course, active sabotage that goes on, usually in conjunction with political events or wartime events, et cetera. So that's actually happening. There's a lot of foothold building going on in the industrial space right now, unfortunately. And it's also a really, really cool field. Oh my gosh, guys, like these are unending challenges for security people. Like, this is a whole new wide world of technologies and vendors and protocols. We need to do a lot of vulnerability research. We need to learn how to do forensics on industrial devices, and we need to know how to do a lot of protocol analysis in these industrial protocols that are proprietary and undocumented, et cetera. And there's a lot of easy wins. Like, I call myself an IT and OT marriage counselor a lot, because a lot of what I do is sit in a room and just mend relationships that have been totally destroyed between operational teams and IT security teams. And doing this has an immediate impact on security posture. We all know there's no unhackable system, but we're building defense in depth, right? We're trying to better our deterrence and better our security posture. So all we can do is keep building onto that and rebuilding those relationships, and doing little bits of research here and there make a big difference. So there's some common misconceptions about OT I want to blast through really fast. So the first one is OT staff don't care about security. They don't care. They're not patching anything. They won't scan anything. Okay, so they do care about security, but what they care about is consequences. And if you don't change, you need to do a big shift in your mental understanding of what's going on in these environments. It's a different perspective completely. And we should have the same perspective in IT, but we suck at risk modeling. So we're really bad at it. OT people think about consequences, and we should too. They think about, my worst day ever is the power going out and a bunch of people dying, or the plane falling out of the sky, or our sewage treatment plant contaminating a body of water. Those are solid consequences that they care about. They don't care if that's caused by an insider doing a cyber attack or a piece of mechanical equipment failing. What they do know is they care about that specific consequence, and then from there they can tree down and think about the things that could cause that consequence. Now, we in IT tend to do like hunting in a vacuum. We say, I'm going to look for a bad guy, so I'm going to look for somebody misusing SMB. Or I'm going to look for somebody who's dumping stuff from a domain controller. We think about things in a vacuum, which is actually really bad. We should be doing this thinking about consequences thing, which is, if the entire industrial network is infected with Conficker, does it cause a consequence we care about? Think about that for a minute. We as IT security people are going to be like, yeah, it's Conficker, we got to clean everything. The OT person goes, okay, I did consequence and risk modeling, and I said, if there's no impact on these systems that will decrease performance by X%, it's fine if they're infected. I've actually modeled this out, and I've evaluated what impact Conficker will have on these systems, and it does not result in a consequence I care about. Now, what would have a consequence is bringing them down for 3 days at millions and millions and millions of dollars of cost. That has a big impact, right? So there's also, ICS is a singular or monolithic thing. So there's a ton of verticals in industrial. We just talked about them all. That's huge. There's hundreds of vendors, and they have thousands of products and product releases. It's a huge space. It's much bigger than IT in a lot of cases. There's way more operating systems and protocols going on in industrial than there is in a traditional IT environment. So there's tons of work to be done there. And none of it looks the same. It's all different analysis and protocol dissection and stuff. And then we have the IT people who see OT systems on Shodan, and they're like, the world's ending, I see a power plant. And maybe it is, maybe it isn't. Industrial systems are really, really complex. We talked about processes earlier. Processes are complex. There's tons of process loops that go into power getting into your house, from generation to transmission. You know, it's tons of stuff going on. And there's lots of safety controls in place because we think about these consequences. So again, we're thinking about consequences. So we think about something exploding. How do we contain that explosion? We don't care if it's a cyber thing that's causing the explosion, but we have to think about that consequence and contain it. So we build in like analog or physical safety controls. Tampering may damage a system or have no impact at all. Poking buttons, maybe there's a safety system in place, maybe there isn't. Maybe there's a human operator there looking at changes, maybe there isn't. An adversary really has to work hard to understand this stuff, and a lot of it takes a ton of reconnaissance. Most industrial attacks we look at take a year of reconnaissance to investigate the system before an impact is attempted. And so simply seeing an HMI in Shodan does not mean that something's going to explode tomorrow. Air gapping. So my industrial network or my OT environment is air gapped, so I don't have to worry about it. Yeah, it's not. That's a lie. It's not air gapped. Maybe if you're really lucky, it's in a different VLAN, which is not air gapping, guys. VLANs, repeat after me. VLANs are not air gapped. VLANs are not air gapping. Come on. Okay, good. All right, you're with me here. It's not. Layer 2 attacks are a real thing, and DMZs in industrial are varied in their actual solidity. There's usually a lot of holes poked through firewalls to the industrial environment for various reasons. There's cloud services in industrial now. There's monitoring services, statistical analysis, historian services, et cetera. So, and there's always people bridging out of the industrial network to like vendors and stuff too, so completely breaking segmentation. And then they're really hard to learn. How am I ever going to move from IT security to OT security? It's really not that bad. You start with a small chunk. You understand that it's a huge space, it's a massive field of its own, and you start with something small. You say, I'm going to learn how to program a PLC, or I'm going to dissect this protocol. I'm going to learn Modbus really well, or learn DNP3 really well. And you just start somewhere. You just start with what's relevant to you and interesting to you, and you start somewhere. And there's lots of familiar IT systems in OT networks. It's full of Windows now, guys. These HMIs that are doing the fancy control screens are all like XP embedded and stuff. So like that's what they are, and that's what they're supposed to be. And some security is better than no security. Like, get out there and try to do something to impact this really important space. So how do you start as a security person getting into OT? So I'll talk about two cases. One is you're in an organization that has an OT team right now and you're trying to fix things and do security better, or you're just interested in doing it as a hobby or a career. So if you have OT in-house, understand that you need to rebuild that relationship. You need to see things from the OT perspective, look at consequences. I recommend donuts when you go in there. You want to meet those operators and try to rebuild that relationship, have good good, easy conversations. Don't come in there looking like an auditor because they hate auditors because auditors don't understand that OT works differently. Understand that things like bad pen tests and bad security audits have probably ruined their perspective and their understanding of what cybersecurity is. And appreciate and leverage the knowledge they have about their systems. They know the processes better than anybody else. And consider how IT and OT convergence can best be achieved in your environments. So how can you share resources? How can you build your incident response and your emergency management plans together, your disaster recovery plans together? Can you use things that they've built? Like they may have really great emergency response plans because they think about these physical consequences. Keep an open mind, that's the bottom line. Fight your biases as a cybersecurity IT professional and try to think like an operator, start trying to think about consequences and about the processes actually in use. So if you just want to learn OT security, you're gonna need to start somewhere, and I recommend starting with the Purdue reference model. Like all things, like the kill chain and like the OSI model, it's not perfect. It's not perfect, and there's endless debates about throwing it out because it's not perfect model. It's educational. It helps you understand kind of how things are put together. It's still a good teaching tool, and it'll help you understand what's in industrial networks. So at the top of the industrial network, you've got your corporate network, and that's like your servers and your workstations and stuff. That's the network you're familiar with. And then there's this DMZ at level 3.5. That's usually that separation, not air gapping, your VLAN that goes into your DMZ, your firewall that goes into your DMZ to go into your operational environment. And that's where you have like jump servers and stuff to get across, and maybe an AV or a patch management relay that goes into that environment. Then beneath that, you've got a bunch of Windows boxes or Linux boxes. Those are like your workstations where your engineers and your operators work, your analysis and patching machines for the industrial systems, your reporting servers, your systems that do like historian services and stuff like that. And beneath that, you start having like operator workstations and your HMIs, your machines that are showing the human-machine interface for the devices, like red light bad, green light good, stuff like that. Beneath that, you've got PLCs. So your more simple computers that are actually issuing controls to the lower level devices, like your actuators that make the door open or make the temperature go up and down, et cetera, et cetera. Or they accept impact from things like sensors that say the temperature is too high or too low. And so you've got very simple devices on the bottom moving up to more familiar IT-like devices at higher levels. And each one of these levels speaks different protocols to the one beneath it and above it. So in one process environment, in one OT environment, you've got a ton of protocols going on, you've got a ton of different devices going on, they're all speaking and functioning together differently, so a lot going on there. So I recommend you spend some time with that and think about what's going on at each level. Find experts in your org, ask them questions, job shadow them if you can. Like, they have a lot to offer. You also can do a lot of OSINT in the space. And yeah, I mean, spend a lot of time on Google and Scribd. You can find manuals that you're not supposed to have for lots of these devices, especially legacy old ones on Scribd. Get out there and start looking into this stuff. Pick a device that's interesting to you or a vertical that's interesting to you. And we do have IT tools that can be used in industrial environments. Wireshark has a ton of industrial protocol dissectors. Remember, your high-level protocols on the Purdue model will be more familiar to you than the lower-level protocols that are like serial or just simple electrical signals. They're going to get weirder as they go down, the Purdue model, but they're also, in many cases, going to get simpler. There's no encryption down there. They're relatively simple things that you can learn. I've got some resources. Take out your phone, take a picture. If you're interested in learning more, here's some blogs that will help you learn more about industrial. I've got a couple at our site that I've worked on, like our reading list and stuff. The one that I did on building the relationship back up between IT and OT teams that goes into this in more depth. And SANS has some great training. There's commercial training out there where you can learn more about industrial, but there's so much open source stuff out there too. So we have just a couple minutes. What questions do you guys have about industrial? What can I answer for you?
So the question, in terms of what you see in real-world implementations with the indirect firewall and data
That's the ultimate question that I get asked in every single talk about industrial that I do. Data diodes. So data diodes are these things you stick in a network connection that only allow traffic one way. And they seem like an awesome idea. You're supposed to put them in your industrial network to keep somebody from accessing things from the wrong direction. Like the thing that's reporting its status can only report up. Nothing can access it downward unless you walk into the building. Sounds awesome. I've seen them in like one facility ever. Nobody actually uses them in practice. And I think it's a lot because these systems are complex and it's hard to do and it's hard to get a maintenance window. We might see more of them in the future, but everybody talks about them in the space, in industrial, and we never see them in use or in wide use at least. Like, it's crazy. Next. Yes, sir.
You mentioned a lot about seeing Windows NT and
Yeah.
embedded. Do you see many Linux environments or is it all Windows?
No, I mean, it's a mix. It's a mix. You even see. Yeah, so am I only seeing Windows out there, especially at higher levels? No, I mean, there's Linux systems out there, but man, building a SQL server is a really easy way to do a historian database. And XP Embedded is a really easy way to build a user interface that's lightweight. Yeah, you see everything, and then down at the PLC level, of course, it's all proprietary operating systems or Arduino, whatever. So, yeah. Yes, sir.
I saw an article a while back that the Russians were at our power grid.
Yes, sir. And we have on our website as a company, we've got a lot of, yes, so, sorry, yes. They're prompting me to read the question. So, is Russia poking at our stuff? Yes, we have a lot of threat intelligence reports for free download on our site about that, about adversaries we're seeing. We do not name nation states in our reports. It seems pretty apparent if you know the correlation between various threat actor names between companies, but we do that for a reason. We never name threat actors. But there are advanced nation state type adversaries that are building good footholds in our environments and doing a lot of reconnaissance about what's out there. I cannot tell you from a geopolitical reason, it's not my place to tell you from a geopolitical standpoint why they are doing that. But I would be very concerned that there are nation-state adversaries, read between the lines here, please. I would be very concerned that there are nation-state type adversaries building footholds and doing extensive reconnaissance of our industrial environments. Oh, God, I don't know who is next. I'm sorry. Yes, sir.
Is there any security remediation success stories?
Success stories. Oh my God. So my marriage counseling stuff, I sit in rooms with they pay not exorbitant, but reasonable amounts of money for me to sit in a room where their IT and their OT teams meet for the first time and they talk to each other. And I say like 5 words. I add in some context like this every once in a while, and they're just meeting for the first time. And that makes all the difference in the world. All of a sudden, the IT team realizes that the OT team has sent somebody to DEF CON one time, and they're really interested in security. And then the OT team is like, wait, you're not going to make me patch the system that has a 20-year support contract that I can't break by upgrading the system? Oh, you get it. Okay, we can talk now. So yeah, all the time. That's a really fun part of my job, is going in and seeing those relationships be rebuilt and people, starting to build better understanding of how those teams are going to converge. Do I have any time for more questions, or? One more. Okay, yes, ma'am.
How often do you see cybersecurity at the design-build portion of a new facility?
I'm not laughing at you, I'm laughing with you. Ma'am, she asked, how often do you see security built into new facilities, new products and stuff in industrial? It's getting a little better, but okay, so the thing, I'll end with this because this is a really important note. The life cycle for industrial devices is really, really long. When you go out and you set up a power plant, you're buying a bunch of stuff at all levels of the Purdue model. You're buying your PLCs, you're buying your historians, you're buying your HMIs, you're buying your engineering workstations from the same vendor. And they all work together because they've been designed to work that way. And you're buying that with like a 20 or 30-year support contract, and to keep using that equipment and have it supported by the vendor. If you upgrade those systems or you modify them, they're either going to stop working with each other across layers, or they're going to stop supporting them. The tech will no longer come out and support them. So yes, the systems being built today have more security built into them. When systems are going to be replaced with those, think more like the decades instead of years. When things break, they get replaced. When there is an outage window once a year, some things things get upgraded. It's a slow process because of the way that these systems are designed and implemented and upgraded. Sorry, I don't think I've got time for any more questions, but catch me outside. Catch me at the bar.